Welcome back to AP Psychology. We'll be talking about Chapter 1, Thinking Critically with Psychological Science today. The scientific attitude reflects an eagerness to skeptically scrutinize competing ideas with an open mind, humility before nature. This attitude, coupled with scientific principles for sifting reality from illusion, prepares us to think critically. Two reliable phenomena, hindsight bias and judgmental overconfidence, illustrate the limits of everyday intuition and our need for scientific inquiry and critical thinking. Psychologists construct theories that organize observations and apply testable hypotheses in their research, and they use case studies, surveys, and naturalistic observation to describe behavior, correlation to assess the relationship between variables, and experimentation to uncover cause-effect relationships. Researchers use statistics to describe their data, to assess relationships between variables, and to determine whether differences are significant. This chapter concludes by briefly answering several questions that are commonly asked about psychology. These include concern over the simplification of reality in the laboratory experiments, the generalizability of research in terms of culture and gender, and the purpose of animal studies, the adequacy of research ethics, and potential misuse of psychology's knowledge. With the impression of psychology, with hopes of satisfying our curiosity, many people listen to talk radio counselors and psychics, to talk radio counselors and psychics to learn about others and themselves. Many people believe that the intuition and common sense are enough to bring forth answers regarding human nature. Intuition and common sense may aid queries, but they are not free from error. Personal interviewers may rely too much on their gut feelings when meeting with job applicants. And for instance, if common sense is also a problem. For instance, if you fold a piece of paper just 0.1 millimeter thick 100 times, common sense would tell you how thick would it be. Well, in reality, it would be 800 trillion times the distance between the sun and the earth. So it would be pretty thick. Hindsight bias is the I knew it all along phenomena, and after learning the outcome of an event, many people believe they could have predicted that very outcome. We only knew the .com stocks would plummet after they actually did plummet. Sometimes we think we know more than we actually know, and how long do you think it would take to unscramble these anagrams? The hindsight bias is also known as the I knew it all along phenomena. The tendency to believe after learning an outcome that one would have foreseen it. Finding out that something has happened makes it seem inevitable. Thus, after learning the results of a study in psychology, it may seem obvious to common sense. However, experiments have found that events far less obvious and predictable beforehand than in hindsight. Sometimes psychological findings even jolt our common sense. Sharon L. Hannigan and Mark Tippen-Reinitz facing a fascinating study of causal inference errors. In a series of 3 experiments, they showed how memory illusions may occur as people attempt to make sense out of events. Research participants saw pictures depicting some kind of effect, for example, oranges sprawled on the supermarket floor, or a student toppling onto the floor. Hannigan and Reinitz later showed the same participants a picture of the most probable cause of the effect: someone reaching for an orange at the bottom of the stack, or a student leaning back in a chair, and asked them if they had seen the picture before. A statistically significant number said that they had. In an effort to understand the world, the participant filled the gaps of missing scenes by claiming they saw pictures there in the first place. The causal reasoning may have been accurate, but their memories were illusions, confident but incorrect. It is surprising that just a few minutes after seeing the effect scene, some people would reliably claim to have seen the cause scene. Says Reince, after all, we tend to believe that we can accurately remember what we saw just a few minutes ago. Memory for pictures tend to be more accurate than memory for words. We put a lot of confidence in things that we have seen with our own eyes, suggests Reince. So applications to the real-world situations are probably more varied and interesting than would be the case if we used text. Hannigan and Reince found that memory errors increased with longer retention intervals. Application to eyewitness testimony in the courtroom is clear. Typically, cases go to trial many months after the events occur, very likely making eyewitnesses more vulnerable to inference-based errors. Misremembering the causes of others' behavior over long periods may also foster conflict in social relationships. Importantly, the research indicated that causal inference errors were common in a backward but not forward direction. That is, exposure to effect pictures caused illusionary memories of seeing cause pictures, but exposure to cause pictures did not produce false memories of seeing effect pictures. The research speculate that there is a stronger need to answer why than to answer what would. People said it would take about 10 seconds, yet on average they took about 3 seconds to answer the anagrams. So overconfidence plays a factor. Our everyday thinking is limited by our tendency to think we know more than we do. Asked how sure we are of our answers to factual questions, we tend to be more confident than correct. College students' predictions of future behaviors and experts' predictions of political, economic, and military outcomes are similarly overconfident. Despite lackluster predictions, the overconfidence of experts is hard to dislodge. So how can we differentiate between uniformed opinions and examined conclusions? The science of psychology helps make these examined conclusions, which leads us to understanding how people feel, think, and act as they do. The scientific attitude is composed of curiosity, passion for exploration, skepticism, doubting and questioning, and humility, ability to accept responsibility when wrong. The scientific attitude reflects a hard-headed curiosity to explore and understand the world without being fooled by it. The eagerness to skeptically scrutinize competing claims requires humility because it means we may have to reject our own ideas. This attitude, coupled with scientific principles for sifting reality from illusion, helps us winnow the sense of from nonsense. It carries into everyday life as critical thinking, in which we examine assumptions, discern hidden values, and evaluate evidence and assess conclusions. Critical thinking does not accept arguments and conclusions blindly. It examines assumptions, discerns hidden values, and evaluates evidence and assesses conclusions. Psychologists, like all scientists, use the scientific method to construct theories that organize, summarize, and simplify observations. A useful theory effectively organizes a wide range of observations and implies testable predictions called hypotheses. by enabling us to test and reject or revise a particular theory which predictions give direction to research. They specify in advance what results would support the theory and what results would disconfirm it. As an additional check on their own biases, psychologists report their results precisely with clear operational definitions of concepts. Such statements of the procedures used to define research variables allow others to replicate or repeat their observations. Often research leads to a revised theory that better organizes and predicts observable behaviors or events. A hypothesis is a testable prediction often prompted by a theory to enable us to accept, reject, or revise theory. For instance, people with low self-esteem are apt to feel more depressed. Research would require us to administer tests of self-esteem and depression on individuals who score low on self-esteem and test high in depression. Test would confirm our hypothesis. A case study is a technique in which one person studies in depth to reveal underlying behavioral principles. The case study is a method by which a psychologist analyzes one or more individuals in great depth in hopes of revealing things true to us all. While individual cases can suggest fruitful ideas, any given individual may be atypical, making the case misleading. Mark Leary defines a case study as a detailed study of a single individual, group, or event. Although case studies of individuals are most common, researchers may also perform case studies of groups. For example, Chapter 18 social psychologist Irving Janis studied several political and military decision-making groups in an effort to understand why groups sometimes make bad decisions. Educational psychologists sometimes study exemplary schools in an attempt to understand why particular schools are so good. Ethologists have conducted case studies of troops of baboons, chimpanzees, gorillas, and non-human animals. Typically, the researcher produces a narrative of the person, group, or event and objective measures of personality or behavior and may be supplemented by the researcher's subjective impressions. Leary identifies 4 uses of the case study in behavioral research. First, as the text suggests, a case study may be used as a source of insights and ideas, particularly in early stages of investigating a specific topic. For example, Freud's theory of psychoanalysis emerged from his case study of therapy clients. Piaget's theory of cognitive development arose from case studies of his own children. Janis' case studies of decision-making groups sets the stage for his theory of groupthink, and Fettensinger's case study of groups that predicted the end of the world led to his influential theory of cognitive dissonance. Second, case studies may be used to describe a particularly rare phenomena. The study of presidential assassins is necessarily limited to case studies of few people who have killed presidential assassins, is necessarily limited to case studies of a few people who have tried to kill U.S. presidents. Investigations of mass murders are limited to a case study approach. Luria used a case study to describe another rare phenomenon of a man who nearly perfect memory. Neuropsychologists sometimes conducted case studies of people with nervous systems that have been damaged because of unusual injury or disease. Oliver Sacks, the man who mistook his wife for a hat, provides a wonderful example. Third, case studies in the form of psychobiographies involve the application of psychological concepts and the theories in an effort to understand the lives of famous people such as Da Vinci, Martin Luther, Mahatma Gandhi, Nathaniel Hawthorne, and Richard Nixon. Sometimes the investigator attempts to explain the person's entire life. In other cases, he or she studies only specific aspects of the person's behavior. Obviously, such reports involve post hoc explanations. Finally, case studies provide illustrative anecdotes. Researchers and teachers often use case studies to illustrate general principles to other researchers and to students. Leary notes that scientists must often convince others of the usefulness and importance of their findings, although never providing proof of an assertion. Case studies can be used to provide concrete examples of abstract concepts and processes. There are at least two important limitations for case studies. First, they are virtually useless in providing evidence to test behavioral theories or treatments. The lives and events studied occur in uncontrolled fashion and without comparison information, no matter how reasonable the investigator's explanation. Alternative explanations cannot be ruled out. Second, most case studies rely on observations of a single investigator. Thus, we often have no way of assessing the reliability or validity of the researcher's observations or interpretations. Because the researcher may have vested interest in the outcome of the study, for example, whether a therapy works, one must always be concerned about self-fulfilling prophecies and demand characteristics. So a case study is a clinical study. A clinical study is a form of case study in which the therapist investigates the problems associated with a client. A survey is a technique for ascertaining the self-reported attitudes, opinions, or behaviors of people, usually done by questioning a representative random sample of people. The survey looks at many cases in less depth and asks people to report their behavior or opinions. Asking questions is tricky because even subtle changes in order or wording of a question can dramatically affect their responses. Wording can change the results of a survey. For instance, if we were to ask the question, should cigarette ads and pornography be allowed on television, would that be a better way to use the word allowed versus forbid? A tendency to overestimate the extent to which others share our beliefs and behaviors often leads to a false consensus effect that some surveys can help us overcome. In everyday experience, we are exposed to a biased sample of people who mostly share our attitudes and habits. As a result, we are vulnerable to our false consensus effect, whereby we overestimate others' agreement with us. The survey ascertains the self-reported attitudes or behaviors of the population by questioning a representative random sample. Obtaining a representative sample of even a well-defined population may not be easy. The challenge of selecting a representative sample is apparent in efforts to predict the outcome of the U.S. presidential elections every 4 years. To predict the outcome, one needs, of course, a representative sample of all adult Americans who will actually vote in an election, not all adult Americans. According to 2000 census, the election results, only 70% of those eligible to register to vote actually did so. Thus, the election poll that draws from a pool of registered voters will be more accurate than one drawing from all those who are eligible to register. Still, only 86% of registered voters actually made it to the polls. In short, of all those eligible to register, only 60% voted. Furthermore, one cannot just take the voter's word that he or she will vote. About a third of those who say they will vote never show up. Voting, like charitable giving, is socially desirable, something people tend to overstate. Another complication of obtaining a representative sample of voters is that all major polling organizations use the telephone to contact respondents. This means those who do not have a phone are automatically eliminated. Statistically, very few people don't have phones, and so this may no longer have a major impact. However, in most recent elections, those who use only cell phones and thus do not have landlines were likely eliminated, a factor that could be potentially affecting polling outcomes. A more persistent problem has been the time of day that calls are made. Shortly after 2004, in the New Hampshire primary, the Washington Post criticized polling giant John Zogby for relying on daytime polling. Although this allowed him to finish polls more quickly and grab the headlines, it may also mean that his samples contained a disproportionate number of retirees and housewives. Almost all polls, including those predicting elections, overrepresent a friendly or social people whose disposition makes them less likely to hang up the phone. Refusal rate to participate in a phone survey in the United States is sometimes as high as 60 to 80%. If those who say no are different from in any way from those who agree to talk, the sample is biased. Exit polls of those who actually vote demonstrate how fatal this last bias can be. Although exit pollsters may face none of the usual polling problems in obtaining representative sample, for example, using landlines, contacting non-voters, or having to call at certain times of the day. The fact that those voting for a particular candidate may be more willing to talk can skew results. Thus, while an early exit polls in 2004 suggested that John Kerry would replace George Bush as the next president, they were quickly proven wrong. Among the factors that contributed to this failure was the fact that younger voters who were more likely to vote for Kerry were also more willing to talk to similarly young pollsters. In short, even exit polls faced the challenge of obtaining truly representative samples. Some findings from Mel Poritz and Bill Sinrod's The First Really Important Survey of American Habits. The survey asked respondents about their eating and sleeping and dressing habits, as well as information about their special abilities and eccentricities. Some findings, a total of 68%, rolled toilet paper over the spool. 79% squeezed the toothpaste from the top. 7% looked behind the shower curtain when using someone else's bathroom. 80% eat corn on the cob in circles rather than from side to side. The results are based on responses from a sample of 7,000 out of 25,000 received questionnaires. In Bernice Canner's recent Are You Normal survey also provides some entertaining survey data, including the fact that 50% eat their Oreos whole, 18% twist the halves apart, and 15% dunk them. The rest smash them or add them to another dessert. 10% have seen a ghost. 27% skip ahead to find out what will happen in a book. 7% have lost their teeth with a hair. However, Canner gives no information on how these results were obtained. The moral: before believing survey results, consider the sample. Canner's more recent Are You Normal about love, sex, and relationships. For interesting survey results, 6% of marriage proposals are made by phone. 67% of women consider themselves romantic, and 58% of men and women believe you should follow your heart rather than your head in choosing a partner. Phone-in surveys may be similarly biased. When television stations conduct such surveys asking viewers to call one number to register yes vote or a no vote, only those who feel strongly enough to invest 50 cents or $1 charge for each call are likely to vote. Not a representative sample. Obtaining random samples for any purpose is difficult. The government has more success than private pollsters. The 1970 draft to determine the order of induction into military service was almost uncertainly unfair. The 31 capsules for January birthdays were placed in the bin first, the 29 capsules February 2nd, and so forth until December 31st was included. Apparently, there was not enough turning in the bin, for December dates were disproportionately represented among the early draws, whereas dates from the first month of the year came up near the end, significantly more often than chance would dictate. So random sampling is a key to this. So if each member of a population has an equal chance of inclusion into a sample, it is called a random sample. It's unbiased. If the survey sample is biased, its results are not valid. The fastest way to know about a marble color ratio is to blindly transfer a few into a smaller jar and then count the smaller jar. Naturalistic observations are observing and recording the behavior of animals in the wild and recording self-seeding patterns in a multiracial school lunchroom constitute naturalistic observations. Naturalistic observations consist of recording behavior of organisms in their natural environment. Like the case study and survey method, this research strategy behavior describes behavior but does not explain it. Case studies, surveys, and naturalistic observations describe behaviors. When surveys and naturalistic observation reveal that one trait or behavior accompanies another, we say the two correlate. A correlation coefficient is a statistical measure of relationship. A positive correlation indicates a direct relationship, meaning that two increase together or decrease together. A negative correlation indicates an inverse relationship, as one thing increases, the other decreases. Researchers depict scores on graphs called scatterplots. Each point values depict scores on graphs called scatterplots. Each point plots the value of two variables. The correlation coefficients helps us to see the world more clearly by revealing the extent to which the two things correlate. So when one trait or behavior accompanies another, we say the two correlate. The correlation coefficient is a statistical measure of relationship between two variables. Scatterplot is a graph comprised of points that are generated by values of two variables. The slope that depicts the direction, while the amount of the scatter depicts the strength of the relationship. The scatter plot on the left shows the negative correlation, while the one on the right shows no relationship between variables. The tendency to interpret correlations in terms of cause and effect is a common error, giving students some practice. For instance, Hippocrates' delightful good news survey was designed to illustrate errors that can be hidden in seemingly sound scientific studies. The survey found that people who often ate frosted flakes as children and had half the cancer rate of those who never ate cereal. Conversely, those who often ate oatmeal as children were 4 times more likely to develop cancer than those who did not. Does this mean frosted flakes prevents cancer while oatmeal causes it? Cancer tends to be a disease of later life. Those who ate frosted flakes are younger. In fact, the cereal was not around when older respondents were children, and so they are much more likely to have eaten oatmeal. The Good News survey, finding that children who took vitamins were more than twice as likely to go on to use marijuana and cocaine, was also likely due to the respondents being younger than average. Finally, the GNS revealed that people who had routine physicals in the previous 3 years were twice as likely to report high blood pressure and cholesterol levels. Do physical exams cause health problems? No, the survey researchers suggest that unmasking bias is probably operating with those having had physicals simply more likely to know they have a problem. Neil Salkett poses the interesting correlation. A local police chief in a small Midwestern town finds that as ice cream consumption increases, the crime rate increases. As people eat less ice cream, the crime rate decreases. What explains this relationship? Is it a causal connection, or is there something these two variables have in common? Both ice cream consumption and crime rate are related to a third variable, outside temperature. When it's warm outside, as it is in the summer, people enjoy the treat of ice cream, and more crimes are committed because it stays light longer, people are outdoors, and windows are kept open. During long, dark winter months, people eat less ice cream and fewer crimes are committed. Scientists have linked television watching with childhood obesity. In fact, the degree of obesity rises 2% for each hour of television viewed per week by those aged 12 to 17, according to the study of Journal of American Academy of Pediatrics. One explanation is that TV watching results in less exercise and more snacking, often on high-calorie, low-nutrition foods pitched in commercials. Is the conclusion justified? What are some of the alternative explanations for the correlation? The causal relationship may be reversed. Obesity may lead children to prefer more sedentary activities, such as TV viewing, or some third factor may explain the relationship. For example, parents having little formal education may not emphasize good nutrition or good use of leisure time. Children with high self-esteem also tend to have high academic achievement. Why is this? Some might argue that the healthy self-concept boosts school achievement. Others convinced that high achievement produces favorable self-image. Reports of recent nationwide sample indicate that neither is true. In other words, self-esteem and achievement are only causally connected. Rather, their correlation is due to their both being linked to intelligence and family social status. Remove the effects of these two variables and the correlation between self-esteem and achievement evaporates. In his best-selling book, Numeracy, Mathematical Illiteracy and Its Consequences, John Paulos gives several examples of how two variables may be correlated because of relationship to a third factor. For instance, a positive correlation between milk consumption and the incidence of cancer in various societies is probably explained by relative wealth of these societies, bringing about both increased milk consumption and more cancer as a function of greater longevity. In the New Hebrides Islands, body lice were at one time thought to produce good health. When people became ill, their temperatures rose and caused the body lice to seek more hospitable abodes. Both the lice and good health departed with the onset of the fever. Similarly, the unexpected positive correlation between the quality of a state's daycare programs and the reported rate of child abuse is not causal, but merely indicates the better supervision results in more consistent reporting of incidents. This scatter plot shows the relationship between height and temperament. There is a moderate positive correlation that we see. Perhaps the most irresistible thinking error is to assume the correlation proves causation. Correlation reveals how closely two things vary together and thus how well one predicts the other. However, the fact that events are correlated does not mean that one causes the other. Thus, while correlation enables prediction, it does not provide explanation. Illusionary correlation is the perception of a relationship where no relationship actually exists. So if we use this chart, we can see that parents conceive children after adoption. So we make this grid here, and we can see that how that scores. Keith Stanovich has identified two major classes of ambiguity. In a correlational research, the directionality problem, the third variable possibility, he illustrates each with the misinterpretation of important consequences. Directionality problem. Researchers have long known about the correlation between eye movement patterns and reading ability. Poorer readers have more erratic patterns, moving their eyes from right to left and making more stops per line in text. In past, however, some educators concluded that deficient oculomotor skills caused reading problems and so developed eye movement training programs as a corrective. Many school districts may still have eye movement trainers representing thousands of dollars of equipment gathering dust in their storage basements. Careful research has indicated that eye movement reading ability correlation reflects a causal relationship that runs in the opposite direction. Slow word recognition and comprehension difficulty lead to erratic eye movements. When children are taught to recognize words more efficiently and to comprehend better, then eye movement becomes smoother. Training children's eye movements does nothing to enhance their reading comprehension. Third variable possibility, in the earliest 20th century, thousands of Americans in the South died from pellagra, a disease marked by dizziness, lethargy, running sores, and vomiting. Finding that families struck with this disease often had poor plumbing and sewage, many physicians concluded that pellagra was transmitted by poor sanitary conditions. In contrast, Surgeon General Joseph Goldberger thought that this illness was caused by an inadequate diet. He felt that the correlation between sewage conditions and pellagra did not reflect a causal relationship, but the correlation arose because the economically disadvantaged were likely to have poor diets as well as poor plumbing. How was the controversy resolved? The answer demonstrates the importance of an experimental method. To prove he was right, Goldberger not only had himself injected with the blood of a victim, he also actually ate the excrement of pellagra victims. Oh my God. Finally, he selected two patients, one with scaling sores and the other with diarrhea. He scraped the scales from the sores, mixed the scales with 4 cubic centimeters of urine from the patient, added an equal amount of liquid feces, and rolled the mixture into little dough balls by an addition of 4 pinches of flour. The pill was taken voluntarily by him, by his assistants, and by his wife. None of them came down with pellagra. To further make this case, Goldberger asked 2 groups of Mississippi State Prison firemen to volunteer for an experiment. One group was given high carbohydrate, low protein diet that Goldberger suspected to be the culprit, while the other group received a balanced diet. Within months, the former group was ravaged by pellagra, while the later showed no signs of the disease. So given random data, we look at order for meaningful patterns. Your chances of being dealt either of these hands is precisely the same, 1 in 2,598,960. Given large numbers of random outcomes, a few are likely to express order. So illusionary correlation is the perception of a relationship where none exists. It often occurs because our belief that the relationship exists leads us to notice and recall confirming instances of that belief. Because we are sensitive to unusual events, we are especially likely to notice and remember the occurrence of 2 such events in sequence. For example, a premonition of an unlikely phone call followed by the call, or that full moons cause erratic behavior. Like other sciences, experimentation is the backbone of psychology research. Experiments isolate causes and their effects. Illusionary correlation is also a result of natural eagerness to make sense of our world. Given even random data, we look for meaningful patterns. We usually find order because random sequences often look random. Apparent patterns in streaks, such as repeating digits, occur more often than people expect. Failing to see random occurrences for what they are can lead us to seek extraordinary explanations for extraordinary events. An event that happens to be 1 in 1 billion people every day occurs about 6 times a day, 2,000 times a year. Psychologist Michael Shermer brings the principle closer to home when he suggests that the law of large numbers guarantees that the 1 in a million miracle happened 295 times a day. And American physicist Freeman Dyson states, during the time that we are awake and actively engaged in living our lives, roughly for 8 hours each day, we see and hear things happening at a rate of about 1 per second. So the total number of events that happen to us is about 30,000 per day, or about 1 million per month. With few exceptions, these events are not miracles because they are insignificant. The chance of a miracle is about 1 per million events, and therefore we should expect about 1 miracle to happen on the average of every month. One common claim of the supernatural is a person's report of having a dream or thought about the death of a friend or relative, and then receiving a phone call 5 minutes later about the unexpected death of that very person. Can such an event possibly be due to chance? Physicists George Charpak and Harry Broach suggest that each occurrence should be expected. Suppose 10 people you know die each year, and that you think that about each person once a year. 1 year contains 105,120 5-minute intervals during which you might think about each of the 10 people. A probability of 10,512, certainly an improbable occurrence. However, there are 295 million Americans. Assume that they think like you, and that makes 77 people a day for whom this improbable premonition becomes probable. If just a few of these people report their experiences to the media, the paranormal is vindicated. In his book Intuition, David Myers gives another excellent example of how we fail to appreciate the streaky nature of random data. Many mathematicians believe the digits of pi reflect a truly random sequence, but this random sequence is likely to include each person's birth date. For example, 3/12/89 begins at the 97,574th decimal place. So many factors influence our behavior. Experiments manipulate factors that interest us, while other factors are kept under control. Effects generated manipulated factors isolate cause and effect relationships. The experiment is a research method in which investigators manipulate one or more variables to observe the effect of some behavior or mental processes while controlling other relevant factors. If a behavior changes when we vary an experimental factor, then we know the factor is having a causal effect. In evaluating drug therapies, patients and experimenter assistants should remain unaware of which patients had real treatment and which patients had placebo treatment. In many experiments, control is achieved by randomly assigning people either an experimental condition where they are exposed to treatment or a control condition where they are not exposed. An independent variable is a factor manipulated by the experimenter. The effect of the independent variable is the focus of the study. For example, when examining the effects of breastfeeding upon intelligence, breastfeeding is the independent variable. A dependent variable is a factor that may change in response to an independent variable. In psychology, it is usually a behavior or mental process. For example, in our study on the effect of breastfeeding upon intelligence, intelligence is the dependent variable. Often our research participants are blind, uninformed about what treatment, if any, they are receiving. One group may receive treatment while other group receives a placebo, the pseudo treatment. Often both participant and research assistant who collects the data will not know which condition participants is in, the double-blind procedure. The placebo effect is well documented. Just thinking one is receiving treatment can lead to symptom relief. The independent variable is the experimental factor that is being manipulated. It is the variable whose effect is being studied. The dependent variable is the variable that may change in response to the manipulations of the independent variable. It is the outcome factor. Assigning participants to the experimental, the breastfed group, In the control, formula-fed group, conditions by random assignment minimizes pre-existing differences between the two groups. The summary of the steps during experimentation: you have random assignment, controlling for the other variables such as prenatal, parental intelligence, and environment. The experimental condition receives the independent variable of breast milk, and the dependent variable is the intelligence score of the child at age 8. The condition for the control group would be the independent variable would be they would receive formula, and their dependent variable would be intelligence score at age 8. So below is a comparison of different research methods. You have the descriptive, correlational, and experimental. The basic purpose of the descriptive method is to observe and record behavior. It's conducted through case studies, surveys, and naturalistic observation. Nothing is manipulated, and the weakness is no control variables. Single cases can often be misleading. The basic purpose of correlational methods is to detect naturally occurring relationships to assess how well one variable predicts another. It's compute statistical associations, sometimes among survey responses. What is manipulated? Nothing. What the weakness is, it does not specify cause and effect. The experimental method is the basic purpose is to explore cause and effect. It's conducted by manipulating one or more factors to use random assignment. The independent variable is what's being manipulated, and sometimes it's not feasible. Results may not be generalized to other contexts. Sometimes it's not ethical to manipulate certain variables. Statistical procedures analyze and interpret data, allowing us to see what the unaided eye often misses. Statistics helps us to organize and make inferences from data. They enable us to evaluate big, round, undocumented numbers, and they often misread reality and mislead the public. Few people detect correlation between height and temperament. Simply by viewing the data, Dennis Jennings and his colleagues have documented our fallibility in detecting correlation. Jennings and his colleagues provided college students with 3 sets of paired data to examine. One set contained 10 pairs of numbers, and another set contained drawings of 10 men of different heights with walking sticks of different length, and a final set consisted of audio tapes of 10 people saying the letter of the alphabet and then singing a musical note. The relationship of the interest was the relationship of people saying the interest was the alphabetical position of the letter and duration of the note. The pair of variables within each set of data correlated between 0 and a perfect 1. Students were asked to indicate the presence of the strength of any relationship. The results indicated the participants did not reliably detect a relationship in the 3 data sets until the correlation reached 0.6 or 0.7. For example, when the correlations were between 0.2 and 0.4, quite typically those found in psychological research, they estimated the relationship to be barely above 0, actually an average of 4 to 8 points on the 100-point scale. Only when correlations were more than 0.8 did participants' ratings average 50 on the 100-point scale. Even correlations of 1 elicited average ratings of less than 85. In short, moderately strong positive correlations went undetected, and very strong correlations were judged as moderate in size. A meaningful description of data is important in research. Misrepresentations may lead to incorrect conclusions. Bar graphs provide one way to organize and present distributions of data. The visual display permits comparisons between different groups on the same quantitative dimension. Reducing or expanding the range of that measure can make differences between groups appear smaller or larger. It is always important to read the scale of labels and note the range. The mode is the most frequently occurring score in a distribution. The mean is the arithmetic average of a distribution obtained by adding scores and then dividing by the number of scores. It is biased by a few extreme scores, and the median is the middle score in the distribution. Half the scores are above it, or half the scores are below it. So these are our measures of central tendency: mode, mean, and median. Mode is the most frequently occurring score in a distribution. Mean is the arithmetic average of scores in a distribution obtained by adding scores and then dividing the number of the scores that were added together. Median is the middle score in the rank order distribution. Measures of central, so you can have a skewed distribution. The difference between the highest and lowest scores in a distribution is the range. The standard deviation is the computed measure of how much scores vary around the mean. A statistical statement of how frequently an obtained result occurred by experimental manipulation or by chance is making inferences. When is an observed difference reliable? Representative samples are better than biased samples. Less variable observations are more reliable than more variable ones. More cases are better than fewer cases. When is a difference significant? When sample averages are reliable and the difference between them is relatively large, we say the difference has statistical significance. For psychologists, this difference is measured through alpha level set at 5%. Important principles to remember in making generalizations include representative samples are better than biased samples. We are particularly prone to overgeneralize from vivid cases at the extremes. Less variable observations are better than those that are more variable. Averages are more reliable than when derived from scores with low variability. More cases are better than fewer. Small samples provide less reliable estimates than the average than do large samples. A frequently asked question is, can laboratory experiments illuminate everyday life? The answer would be, artificial laboratory conditions are created to study behavior in simplistic terms. The goal is to find underlying principles that govern behavior. Psychologists use tests of statistical significance to help them determine whether differences between groups are reliable. When the averages of the samples are drawn from the groups are reliable and the difference between them is large, we say the difference has statistical significance. This means that the difference very likely reflects a difference and is not due to a chance variation between samples. Given large enough or homogeneous enough samples, a difference between them may be statistically significant, yet have little practical significance. Does behavior depend on one's culture? Answer, even when specific attitudes and behaviors vary across cultures, they often do, and underlying processes are much the same. The experimenter intends the laboratory experiment to be simplified reality, one in which important features can be simulated and controlled. The experiment's purpose is not to recreate the exact behaviors of everyday life, but to test theoretical principles. And it is this resulting principle, not specific findings, that help explain everyday behavior. In an attempt to overcome the artificiality of the laboratory environment, Some researchers conduct field experiments. For example, do race and sex of a person who requests help influence our generosity? Brigham and Richardson attempted to answer that question with a field experiment. Confederates entered a convenience store and attempted to buy an item that cost $1.15 and $1.50. When it came time to pay the sales clerk, they found they had only $1. They asked the clerk would sell it for less. In this experiment, they had the salespersons were the research participants, and the independent variables were the sex, male and female, and the race, black and white, of the shoppers. The dependent variable was the clerk's willingness to sell the item for $1. Results indicated that both whites and females were more likely to be treated generously. It could be made clear to students that when the field experiments gain in realism, they often lose in terms of control over extraneous variables. Critics have also argued that field experimentation involves an invasion of privacy because the participants are observed without their knowledge or consent. Field researchers have argued that the rights of participants are protected by preserving their anonymity and by not subjecting them to conditions that they would not otherwise encounter. Although culture shapes our specific attitudes and behaviors, the principles that underlie them vary less. Our shared biological heritage unites us as members of the universal human family. Studying gender differences is only interesting but also potentially beneficial in preventing conflict and misunderstandings of everyday relationships. It is important to remember, however, that psychologically as well as biologically, women and men are overwhelmingly similar. Cultural diversity is a factor in research and some differences in cultural norms. Here are some examples. Hissing is a polite way to show respect for your superiors in Japan. In the village of Bangchan in Thailand, face-to-face conflict must be avoided at all costs, even to the point of not reporting something unpleasant. For example, one would not say, "Your house is burning." Better to ask, "Why don't you see your house?" The polite way to say no is to giggle. And although women may be greatly disturbed by their husbands taking additional wives, they would say nothing because they would not want to put anyone on the spot. And among the Karyaki of New Guinea, a man is considered abnormal if he is not engaged in homosexual behavior before marriage. In many societies where hunger is endemic, fat women are viewed as much more attractive than slender ones. In Japan, it is quite acceptable for parents to hire an agency to investigate the background of their daughter's potential marriage partner. By leaving some food on the plate, a guest in India indicates the generosity of the host who has put so much food out that no one could eat it all. In fact, well-meaning visitors can find themselves offending their host by following their own custom of eating all the food served to them. Public displays of affection between men and women in Thailand are unacceptable. Interestingly, however, men holding hands is considered a sign of friendship. In Latin cultures, children, especially girls, are socialized to value conformity to social norms. Rebellious delinquency are rare. Mexican adolescents will be reluctant to engage in any activity that might bring shame to their families. Respect for diversity, including norms practiced by cultures radically different from our own, sounds like a wonderful idea, but how should we react when it clashes with some deeply held value such as gender equality? Certainly we will agree that we needn't be accepting of brutality, say genital mutilation, which is common in some African countries, but what about other gender roles and practices in Muslim countries such as Kuwait and Saudi Arabia? Or in Sudan, the requirement that a woman may not leave the country without the permission of her husband or father or brother. In short, at what limits to tolerance? So, Another frequently asked question: does behavior vary with gender? Yes, biology determines our sex. Culture further bends the gender. However, in many ways, woman and man are similarly human and have more in common. Another frequently asked question is, why do psychologists study animals? The answer: studying animals gives us an understanding of many behaviors that may have common biology across animals and humans. Some psychologists study animals out of the interest in animal behaviors. Others do because knowledge of the physiological and psychological process of animals enables them to better understand the similar processes that operate in humans. Because psychologists follow ethical and legal guidelines, animals used in psychological experiments rarely experience pain. The debate between animal protection organizations and researchers has raised two important issues. Is it right to place the well-being of humans above that of animals? And what safeguards are in place to protect the well-being of animals in research? Many professional organizations and funding agencies have developed extensive guidelines for the humane use of animals. Ethical principles for treatment of human participants urge investigators to obtain informed consent, protect subjects from harm and discomfort, and treat information about individuals confidently, and fully explain the research afterward. Psychologists value the influence of their choice of research topics, their theories and observations, their labels for behavior, and their professional advice. Knowledge is a power that can be used for good or evil. Applications of psychology's principles have so far been mostly for the good, and psychology addresses some of humanity's greatest problems. So another question: is it ethical to experiment on animals? Yes. It's ethical to gain insight to the devastating and fatal diseases. All researchers who deal with animal research are required to follow ethical guidelines in caring for these animals. Is it ethical to experiment on people? Yes, it is also ethical to experiment on people. Experiments that do not involve any kind of physical or psychological harm beyond normal levels are encountered in daily life may be carried out. Practically all ethical issues reflect a conflict between the rights of the individual and the possible benefits of research to society. Thus, resolving the issues is always difficult, and psychologists have typically applied cost-benefit analysis. Does the potential benefit of the study in society outweigh the potential cost to its participants? Some find such an analysis appropriate, while others argue that it reflects little more than an ends justifying the means thinking. As a result, recent years of psychologists have developed a heightened sensitivity to the rights of those who volunteer as research participants in their experiments. For example, in response to a problem of pain and anxiety, the principle of informed consent requires that participants be informed of any risks or dangers involved in an experiment before they decide whether to participate. In dealing with the problem of embarrassment, participants must be told from the start that they are free to withdraw at any time without penalty. The controversy over the use of deception in the psychological research is reflected in an exchange between Diana Baumrind and Robert Barron. Baumrind argues that when research participants are given false or incomplete information, they are deprived of their right to decide freely and rationally how they will wish to invest their time and persons. The psychological costs of deception are particularly severe when they reduce the participants' trust in a legitimate authority, negatively affect their ability to trust their own judgment, and impair their sense of self-esteem. Baumrind suggests that debriefing participants does not automatically reverse these undesirable after effects. For example, in Milgram's famous studies of obedience, debriefing did not restore the participants' self-esteem or willingness to trust authorities in the future. Barron responds that Baumrind overstates the potential costs of deception. underestimates both the necessity and potential benefits of such procedures, and moreover, the researchers are sensitive to the use of deception and employ informed consent through debriefing to mitigate the problem. Deception, Barron suggests, is essential in certain studies, for example, in investigating bystander reaction in emergency situations, in analyzing subtle forms of racial bias. The use of temporary deception in the research has enabled important insights into why groups often make more extreme decisions than individuals, why humor may inhibit aggression, and why similarity rather than complementary leads to marital satisfaction. Barron further argues that when participants learn why deception was necessary, they do not seem to experience the negative reactions described by Baumrand. On the contrary, the vast respond positively. Finally, Barron maintains that the insight participants gain into themselves as a result of the debriefing is often valuable experience, even when the information is not flattering. So, is psychology free of value judgments? No, psychology is not free of value judgment. It emerges from people who subscribe to a set of values and judgments. Is psychology potentially dangerous? It can be, but it's not. The purpose of psychology is to help humanity with problems such as war, hunger, prejudice, crime, family dysfunction, etc. This concludes Chapter 1, Thinking Critically with Psychological Science.